Hello and welcome to the fourth lesson in electricity and magnetism. So today we're looking at circuit analysis. So you can use your knowledge of direct current circuits to analyze for unknowns. So this is kind of the stepping stone. If you're going to go into electrical technician, electrical engineering, this is a requirement, being able to do some circuit analysis at the basic level so that you can do the more complicated a little bit later on. So there's a series of rules or strategies for analyzing circuits. I'm going to go through them quickly because experience is the best thing, okay, and trying to kind of a couple of these, but here are your general rules to follow. Fill in any unknown quantities, okay? You're going to be able to look at a circuit and say, oh, I can fill in some quantities here so I have more information. Next, number 2 is fill in any quantities that can be solved using Kirchhoff's laws. So that is your current law and your resistor law. And again, when you see it in practice, and I explain it as we go through, it'll make a little bit more sense. Here's the key one right here. You need to reduce parallel circuits to equivalent series circuits. And again, I'll show you how to do this. It's one of those things that you got to see the process. We draw a series equivalent circuit. So we're really doing step 3 to get to 4, because what we want is we want to create a basic circuit. So we're going to take complicated ones and we're going to simplify it. All right, we want to create a basic circuit. And finally, we're going to use V equals IR to solve for any missing variables. All right, and that's our mainstay. We are just using that formula right there. Okay, so hopefully I left enough room on your printout. This is the circuit we're going to analyze. So I'm going to extend my page just a little bit here. So here it is, solve for all unknowns. This is what I would do, okay? I find the chart system for me keeps everything organized and you can figure out what you know and what you don't know. So the chart system is very simple. We want V equals IR, so I'm going to go V, I, and R over here. And we're going to create a fourth column in front, and we're going to go, we'll go circuit number. Okay, so that we know where we are. So this is what the chart will look like. Every resistor is going to be given a number. So you can't number them wrong. 1, 2, 3, and 4. So that means I have 4 components I need to analyze here. So 1, 2, 3, and 4. And then the last one is going to be my total column. All right, my total column. So let's look at this circuit and fill out what information we know. Okay? We know the battery is a 6-volt battery. All right? That's given information. That is our total voltage. So that's going to go in the total column for our voltage. That's the total voltage. Moving my way around, I know that the resistance at circuit 1 is 10. So at 10, in the column under resistance, I'm going to put 10 ohms for my resistance, and that's all I know at that point. All right, that's all I know. Going through it then sequentially for component number 2 here, the only information given is that the resistance is 12. The third one, I know my resistance is 8. And the fourth one, the resistance is 5. In order to fill in my chart, I need to know 2 pieces of information, okay? Because V equals IR. All right? So with V equal to IR, I need to know 2 of the 3 things in each category. And if you look in this chart, I don't know 2 pieces of information, and that's all that was given to me. All right? So we're going to have to go and seek it out. So what we're going to do is we're going to simplify this circuit. All right, so I'm going to redraw it with my 6-volt battery. I know there should be 6 bars there, but too lazy to draw that many. The first resistor I'm going to leave alone for now. This pathway here that I'm going to circle, I'm going to combine that together to make it 1 resistor. All right, and that 1 resistor, because it's in series, can just be added together. So 12 plus 8 is the equivalent of 20 ohms of resistance on that pathway. All right, then I draw this one in, and it doesn't change because I don't have to combine it. So I now know that that one pathway is 20 ohms. I'm going to redraw the circuit again because I still don't know. The only thing I can go for is total resistance. So that's what I'm heading for. I'm trying to find this value right here. Okay, I need to know the total resistance because that's really the only piece of information I can get. And we do that by simplifying the circuit. So the next drawing, 6-volt battery again, 10 ohm resistor here. What I'm going to do is I'm going to combine these two resistors together. Okay, they're in parallel, so I have to use 1 over R total is equal to 1 over R1 plus 1 over R2. So just the calculation from the other day. My total resistance then, 1/20th plus 1/5. Doing the calculation, I get 1 over my resistance total is equal to 0.25. I then put it to the exponent -1 to flip it over. So my resistance total is now 4 ohms. So those two parallel circuits that I just identified in green, I can squash them together to create one resistor of 4 ohms. So what is the total resistance for my basic circuit? Well, now there's only one pathway, and that's the goal. We got to get it down to one pathway. My resistance total for here is 10 plus 4, or 14 ohms. Okay? We're going to have, I got another example. This is going to take some practice, so don't panic yet. I'll tell you when to panic. So knowing that, I can now fill in my 14 ohms in my chart. Now I have all the information I need to start the process. So looking at the chart, I know that V equals IR. So how do I find this value? And you may not have left space, but I'm going to put it in here. I know that 6 is equal to 14I. Okay? So you can do the calculation below. So what this is going to tell me, it's going to tell me the current for this whole circuit. So 6 divided by 14 is 0.42. So that's the current through the circuit. Okay? So the total voltage is 6. Total resistance is 14. Using V equals IR, 0.42 is my current. Okay, now we start doing some talk. Let's take a look at the pathway possible here. So, leave the battery. So I'm over here right now. I leave the battery, and all the electrons have to go through the first resistor. Everyone's got to go through there. So that means the current through the first resistor is 0.42. Everyone had to go through. Okay? What that does is it gives me two pieces of information, and we know that V equals I times R. So now we can find out that if we started with 6 volts, or if you want to go back to the analogy, 6 pretzels, 4.2 pretzels were 8 going through the first resistor. Okay? Now, over here again, looking at the circuit. So right now I'm at this junction point right here. I want to get to this junction point right here. I have two options. I can go this way on the outside, or I can go through the shortcut. So those are the two options we have. But regardless of which pathway you take, if you go the outside one or through the middle, you have to eat pretzels. How many pretzels are left? Okay, or how many volts are left? Well, I started with 6 volts. I used up 4.2 going through that first resistor, so I ate a lot of pretzels on the first resistor. I now have 1.8 pretzels left for voltage. Okay, 1.8. So if I have 1.8 pretzels here, that means if I go this way, I'm going to eat 1.8. If I go this way, I'm going to eat 1.8. Now, this path right here, you'll notice that there are 2 resistors, so I don't know how I'm going to eat my 1.8. Okay? So I'm going to go and look at the single resistor, because I know there's only one resistor. So if I go through resistor number 4 there, I will eat 1.8 pretzels. Okay? So I can eat 1.8 pretzels going through there. If that's the case, using V equals IR, I'm going to divide 1.8 by 5. And what I find is the current is 0.36. Now we know the total current is 0.42. All right, the total current was 0.42. 0.36 of it is going that direction right there, or that has decided to go this way. So 0.36 is going this way. So now we can figure out, well, how much current's going through there, because if your total current is 0.42 minus 0.36, that means the remaining current is going in through the other pathway. So we get 0.06. So that means that the total current going through number 2 is 0.06, and through the other one is 0.06. All right, that's what's left. So 0.36 is going through the single resistor, 0.06. Now we have V equals IR again. So we do 0.06 times 12, and I get 0.72. 0.06 times 8, and I get 0.48. And I can check because, remember I said earlier, to get from here to here, I'm going to eat 1.8 pretzels. Oops. 1.8 pretzels. So I knew that there. Going through here, that means that these two guys should add up to 1.8. When you do a quick check here, 0.72 plus the 0.48, add that together, plus the 0.48, I get 1.2 pretzels. So I'm off a little bit. So either I did a calculator mistake here, or I rounded too much on my way through, which could be 2. 0.48 plus the 0.72, 1.2. So, all right. So there we go. That is a circuit analyzed. For the first example, I have another example I'll go through and step you through it. So I did a lot of extra calculations here. It looks crazy because I'm showing a lot of steps. If you can do this on your calculator, some of these steps, you're more than welcome. But this is the final answer. This is what I'm looking for when I mark or evaluate your analysis, is that chart. So everything else is kind of the rough work. All right? So I'll do another example in the next video and let you try a bunch, because really practice is the only way to get better at these ones.